Hey everyone, so today we'll be solving the Maths AAHL paper 1, which came out in 2024. And this is part 2 of the series that we have just started. So, in this video, we'll be solving the next 3 questions of paper 1. So, you can pause this video and you can read the question, and we can start solving it now. Okay. Now, for the first part, let's see what are the things that have been given to us. So we have to complete the tree diagram to show the probabilities of not nesting in each season. Okay. So we know, so let's do the first part. So we know that the probability of nesting in spring, the probability of nesting in spring is K, and we know that the probability of nesting in summer is K over 2. Okay. Now for completing the tree diagram, we know that nesting in spring is equals to K. So what will be the probability of not nesting in spring? So the probability of not nesting in spring will be 1 minus K, right? Now let's see what is the probability of nesting in summer. It is K over 2. So this is 2. And what will be the probability of not nesting in summer? It will be 1 minus K over 2. Okay. So we can say that the missing probabilities that we have, spring not nesting is 1 minus K and summer not nesting is 1 minus K over 2. So you can complete the tree diagram by filling in these values. Okay, now let's go to part B. So in part B, we have the first part. We have to show that 9K square minus 27K plus 8 equals 0. And we have the probability of not nesting in spring and not nesting in summer is 5 over 9. So we can say that the probability of not nesting, so I'm just writing it short form, so not nesting in spring and and not nesting in summer is equals to 5 over 9. Now we can substitute the values over here. So what is the probability of not nesting in spring? It's 1 minus K multiplied by 1 minus K over 2, and this will be equals to 5 over 9. So you can expand it and then you can simplify it. So when you'll expand and simplify, this will come out as 9K square minus 27K plus 8 equals 0. So this is the solution for the first part of part B. Okay, now let's do the second part of part B. It's very easy. Now we know that we have to state that y k is equals to 1 over 3 is the only valid solution of this. Now the given solutions are, now when you'll solve this for the value of k, we'll have k equals 1 over 3 and we'll also have k equals 8 over 3. So we know that the probability lies between 0 and 1. So hence 1 over 3 is the valid solution and we'll discard this value which is 8 over 3 because it is greater than 1. So this is the solution for the second part. Okay, now let's move to the next question of this paper. Now you can pause this video and you can read the question and we'll solve it. So first let's solve part A. So you have to find the equation of the horizontal asymptote. Now, for any rational function where numerator and denominator, they both have the same degree, we know that the horizontal asymptote will be the ratio of their leading coefficients. So we can say that fx will be 2x over 3x and this will be equals to 2 over 3. So y equals 2 over 3 is the horizontal asymptote of this equation. Okay, so the equation of the horizontal asymptote will be 2 over 3. Now let's do the second part, which is part B, and we'll solve the first part. Now we have to determine the value of m such that fx equals 3x has only one solution. Now from the graph, you can see that fx has two branches right? And a straight line with positive slope intersects both the branches. So we can say that it will have two solutions. So you just have to observe the graph. Since f of x is having two branches, so we can say that it will have two solutions. Okay. Now let's solve the second part of this. Now we have to determine the okay, I'm so sorry. The first part was that we had to write the number of solutions to fx equals gx. So we found out that there were two solutions. Now the second part, we have to determine the value of n such that fx equals gx has only one solution for x. Now what we are going to do, we are going to algebraically solve this equation. So let's solve 2 multiplied by x plus 3, which is the fx, over 3 multiplied by x plus 2 equals mx plus 1. So when you'll solve this, now how we're going to solve it, we'll multiply both sides by the denominator. So it will come out as 2x plus 6 equals 3 multiplied by mx plus 1 multiplied by x plus 2. Okay. Now when you'll expand it, you'll get something like this: 3mx squared plus 6m plus 1 multiplied by x equals 0. So I just expanded it and got all the terms to one of the sides. Now let's factor it out. So let's take x as common. So this will be 3m plus 6m plus 1 equals 0. Now what will be the solutions of this? So one solution will be x equals 0. This is x. One solution will be x equals 0 and the other solution will be x equals minus of 6m plus 1 over 3m. Okay. So this minus will be here. Okay. So for only one solution, okay, so we have to determine the value of n such that fx equals gx has only one solution. So if for only one solution, both roots must be same, right? We have one root as x equals 0 and we have the other root as minus of 6m plus 1 over 3m. Now for both roots, for having only one solution, both of the roots must be same. So what we are going to do, we are going to equate these two roots. So minus 6m plus 1 over 3m equals 0. So when you solve this, the value of m will come out as negative 1 over 6, which is your answer. Okay. Now let's solve the third part of this question. We have to find the range of m for two solutions with x is greater than equals to 0. So we already have one solution as x equals 0 and we have the second solution as minus of 6m plus 1 over 3m. So these are the two solutions we have. Now for two distinct solutions, it must satisfy this condition: x is greater than equals to 0. So what we are going to do, we are going to substitute minus 6m plus 1 over 3m should be greater than 0. Now when you are going to solve the inequality, there will be some critical points. So those critical points will come out as, now for the numerator, 6m plus 1 equals 0, we'll have the value of m as negative 1 by 6. And for the denominator, 3m equals 0, we'll have m equals 0. So the value of m will lie between negative 1 over 6 and 0. Okay, so this will be the range. Okay, so the range of m for two solutions. Okay, now we'll solve the next question, which is of this paper. Okay, so you can pause this video and you can read the question and then we will discuss it. Okay, so a farmer grows two types of apples. So there are cooking apples and eating apples, right? So the weight follows the normal distribution. Now, what is the first part? We have to find the percentage of eating apples weighing more than 140 grams. Now, let's solve the first part first. Now, the first step that you're going to do is that we'll have to convert 140 grams into standard deviations. Okay, so let's say for eating apples, we have mu as 100 and we have the standard deviation as 20. So let's substitute the values. 140 equals 100 plus 2 multiplied by 20. So 140 grams is exactly plus 2 sigma above the mean, right? We can say that. Now, what we are going to do, the next step is that we'll use a 95% rule. Now, what do we know? That 95% of values lie between or lie within this plus minus 2 sigma, right? Then if 95% of values lie within this range, now can we say that 5% values will lie outside this range? Yes. And by symmetry of the normal distribution, we can say that 2.5% lie above plus 2 sigma. So the final answer will be 2.5 percentage because it will lie above plus 2 sigma. Okay. So that is the answer for the first part. Okay. Now let's solve part B. Now we have to find the probability of an eating apple so that the apple is an eating apple. Now, what is the idea that has been given in the question? The apple is chosen from the container and not from all the apples, right? And the container contains only apples heavier than 140 grams, right? The container contains apples which are heavier than 140 grams. So this is a conditional probability question, right? So what we are going to do, the step one will be, let's find the proportion of each type of apple grown. So let's see, for eating apples, the proportion is 80%. And for cooking cooking apples, the proportion is 20%. Now, from part A, we know that eating apples are heavier than 140 grams. So from part A, we can say that the probability an eating apple weighs, so we can say that the probability that an eating apple weighs more than 140 grams is 0.025, right? Now, we have to include how many apples are eating apples, right? So the probability, we can write it as probability of eating and greater than 140 grams will be zero point 0.8 multiplied by 0.025, which is 0.02. So it means that 2% of all the apples are eating apples which are heavier than 140 grams. Okay. Now, let's find out for cooking apples as well. Now, for cooking apples, I'm just writing here cooking apples. Now, for cooking apples, the mean is 140 grams. And by the symmetry of the normal distribution, we can say that the probability of cooking apple greater than 140 will be 0.5, right? Now, what we are going to do, we are going to include the proportion of cooking apples to this. So, the probability of cooking and greater than 140 grams will be equals to 0.2 multiplied by 0.5. So, this will be 0.10. So, this is equals to 10%. So, we can say that 10% of all the apples are cooking apples heavier than 240 grams. Okay. Now, let's find out the total apples in the container. Okay. So, the container contains eating apples greater than 140. So, that is 0.02. And cooking apples greater than 140 is 0.10. So, the probability of greater than 140 grams will be 0.02 plus 0.10, which will be equals to 0.12. So 12% of all apples end up in the container, right? Now, the last step that we are going to do is we have to find the required probability. So we'll use the conditional probability. So the probability of eating apples, given that it is greater than 140 grams, is equals to the probability of eating apples and greater than 140 over the probability of greater than 140 grams. So this is the formula for conditional probability that we are using here. So we'll substitute the values. This is 0.02 over 0.12. So this will be, when you'll solve it, it will be equals to 1 over 6. So that is the required probability which you have to find. Now, in the next video, we'll be discussing the next 3 questions of paper 1, and I'll be continuing the series. Now, you can also join our WhatsApp online community where we discuss a lot of your doubts and we solve all the problems and past year paper questions, and you can also refer it for resources. So I'm just attaching the link of the online WhatsApp community and you can join it, and we'll meet again in the next video. Till then, take care. Bye. All the very best to you.